Assalamu alaikum and hello everyone. In this video we are going to learn how to solve first order linear differential equations. This is a fundamental topic because these equations appear everywhere in physics and engineering. We will use a powerful technique called the method of variation of constants of Lagrange. So first, let's identify the form of a linear differential equation, which is y prime plus a of x times y equals b of x. Here, a and b are functions of x. If they happen to be numbers, we call it an equation with constant coefficients. So to solve this equation, we follow a two-step process. First, we find the solution to the associated homogeneous equation, which is denoted YH. And in step number 2, we find a particular solution denoted YP. Then we sum them to obtain the general solution of the equation, which is YH, the homogeneous solution, plus the particular solution. Now we are going to see how to find the homogeneous solution and the particular solution. First, let's write the homogeneous equation, which is y prime plus a of x times y equals 0. This is a separable equation. If we move the second term to separate the variables, we can write this, then this, then we write the y terms in one side and in the other side the x terms. Now by integrating the both sides, we get the logarithm of y equals, I am going to use big A of x, which is the antiderivative of small a of x, plus a constant k. You can write y equals the exponential of minus a of x plus k, and here the exponential of k, we are going to note this as a constant c. As you can see, we omit the absolute value since we are looking for a general solution, and the arbitrary constant c can be either positive or negative. And this is our homogeneous solution. Now we need to find a particular solution with variation of constant method. It is also called Lagrange method. We put yp equals to this. We only put c equals to c of x. Here c of x become a function. Now we know that this particular solution is a solution for our original equation. Then to substitute it in this equation, we have to calculate the derivative of yp, which is yp prime equals to c prime times the exponential of minus a of x minus a of a prime of x exponential of minus a of x times c of x. Don't forget that a prime equals of small a of x and here this is the derivative of the particular solution. Now I am going to write our equation a second time, and we are going to put the particular solution here and here. Then we can write c prime of x exponential of minus x plus a of x times yp, which is c of x, the exponential minus a of x equals to b of x. As you can see, the terms with c of x cancel out, and we are left with a simple expression of the derivative of c, which is c prime of x equals to b of x times exponential of a of x. Now to find c, we simply calculate with respect to x, and we plug this here. Okay, then the particular solution become the integral of p of x times a of x dx, or this times the exponential of minus a of x. And this is our particular solution. Finally, we can write the general solution. As I said previously, the homogeneous solution plus the particular solution, which is c times the exponential of minus a of x plus the particular solution, which is the integral of px times the exponential of ax dx times the exponential of minus ax. I know that writing the solution like this is horrible, but we are going to see that it is very easy to find a solution like this. Let's use for this a practical example and take the equation y prime minus y equal to exponential of x. The step number 1 is to find the homogeneous solution of the homogeneous equation y prime minus y equals 0. Then dy over dx equals to y. Then we separate the variables and we write this. Then we integrate to find the logarithm of y equals x plus k. Then we use the exponential to write this. As I said before, we omit the absolute value because c can be positive or negative. Now we found our homogeneous solution. Step number 2 is to find the particular solution. We know that the particular solution is c of x times exponential of x. Here c becomes a function. Y prime equals to c prime of x exponential of x plus exponential of x times c of x. We take our equation. Now we substitute y prime and y here, and we can write c prime of x exponential of x plus exponential of x c of x minus c of x exponential of x equals to exponential of x. Here we cancel this, and we write c prime of x equals to 1, because here we can cancel this by this. Then c of x equals to x. Now our particular solution is x times exponential of x. Now step number 3 is writing the general solution, which is the homogeneous solution plus the particular solution, which is this c exponential of x plus the particular solution, which is x times x, and we can write it in this form, which is the general solution for our linear equation. In summary, solving a linear equation is about finding the homogeneous solution first, and then varying the constant to find the particular solution. This method is very easy and works for any functions a of x and b of x. So in the next video, we'll see how to solve Bernoulli's equations by transforming them into the linear equations we learned today. So see you in the next video, and bye.